So you have delta G equal a negative when it's spontaneous. We have delta G equal a positive when it's not spontaneous. Now an interesting place that's between here is when delta G is equal to 0. And when delta G equals 0, we're at equilibrium. So if you think about it, an isolated system always reaches equilibrium. Isolated means that no heat can enter, no energy can't enter or exit, and matter can't exit or enter. So once if something reaches equilibrium, it has a delta G of 0. But if you think about a cell, if you have delta G equal to 0, that means you have no energy to do work. So basically the cell is dead. So how do we keep a cell from reaching equilibrium? So you know that equilibrium, if you take equilibrium is constant is equal to the products, the concentration of the products over the concentration of the reactants. There's exponents on them. So the equilibrium constant tells you that if we keep changing the values of the, if you keep changing the concentrations of the products and reactants, so in other words, if you keep having things enter and exit the cell constantly, you're not allowing the cell to ever reach equilibrium. So this is a really important factor in a cell, that it never reaches equilibrium, and it's preventing, you want to prevent it from reaching equilibrium so that it doesn't die. So now we're going to look at energy coupling. So energy coupling is when you use exothermic reactions to drive an endothermic reaction. So exothermic, you're losing energy, it's thermodynamically favorable, and endo, you need energy. So the energy that's lost in an exothermic reaction can be used to fuel the endothermic reaction. So in a cell, there are 3 main types of work that needs to be done that you need energy for. The first one is chemical work. The second one is transport work. Transport work is when you have a membrane and things need to go in and out, things like that. And the third type of work that you have is mechanical. And a form of mechanical that we recognize is, if you remember the transfer protein that, looks like it's walking, and that's how it takes things places, so that's a form of mechanical work. So for all of these reactions, you need some kind of energy, and the intermediate or the immediate source of energy to do work in a cell is usually ATP. So people understand until there, but they don't understand how is the energy from ATP able to be used to do work in an endothermic reaction. So ATP stands for adenosine triphosphate. And it's drawn with 3 phosphate groups in its tail, and it's combined to a ribose, which is a form of sugar. And this is attached to adenine. And adenine should be familiar because it was one of the nitrogenous bases in DNA. So the bonds in these phosphate groups at the tail can actually be broken with hydrolysis. And hydrolysis is just the addition of water. So if you have ATP and you add water to it, it breaks this bond here. So now the result is ADP. So instead of triphosphate 3, you have diphosphate, which is 2, plus the phosphate that you just removed. So this reaction is highly exothermic, and you have negative 7.3 kilocalories per mole of energy that's released. So now if this is releasing energy, this can be coupled with another endothermic reaction, endergonic reaction, to have it overall be exergonic. So to repeat that, So you have a negative 7.3. If you have a positive number that's less than if you have a positive number that's less than the magnitude of 7.3, the overall reaction can still be negative. So to explain this, we're going to look at what phosphorylating an intermediate means. So the example we're going to look at is you have glutamic acid, and we're just going to represent that with a triangle, combining with ammonia, we're going to say it's a circle, resulting in glutamine. And let's say that's what it looks like. Now the only problem with this is that it's an exergonic reaction. So you have delta G is equal to positive 7.3 kilocalories per mole. So you need this much energy to be able to fuel this reaction. So this is where ATP comes in. So with ATP being used, you have the glutamic acid, and we're going to add ATP to this. So what happens here is phosphorylation. So the P from ATP, this tail, is going to go and be covalently bonded to the glutamic acid. And we're going to add this P, and then you have the ADP left. Then we're going to add NH3 to here, and this is going to give you the same result, glutamine, except the overall reaction is now going to be an exergonic reaction. Overall, you get negative 7.3 kilocalories per mole. So overall, it's remained exergonic. So to understand what just happened here is when you're phosphorylating the intermediate, in this case, the intermediate was our glutamic acid, when you added the P, it makes the glutamic acid very unstable. So when something's unstable, it has more free energy because it wants to be able to change. So the more free energy it has, remember free energy is final minus initial to get the delta G, the more higher free energy it has, the overall reaction is able to still be exergonic. So we know that ATP hydrolysis is exothermic, but once all these ATPs are being used to phosphorylate different intermediates, we are left with all this ADP, and we need more ATP. So that's where ATP regeneration happens. So this is where ATP is hydrolysized, and regeneration, you have ADP, and you have to add the phosphate group to get ATP. So this reaction happens in a cycle. This is just called the ATP cycle. So we know that energy from here to the hydrolysis releases energy, and this energy can be used for cellular work. So if this is endergonic, how do we get this energy? So catabolic reactions that happen in the cell, they all release energy. They're always exergonic. So you have catabolic reactions in the cell being able to fuel the energy needed for ATP regeneration. And overall, this is known as the ATP cycle. So that's how coupled reactions work with ATP, and I hope this video helped you understand why ATP can be used as an intermediate to allow endergonic reactions to still be able to happen. Leave in the comments below if you have any other requests for videos, any topics that are that you're struggling with, and I'll see if I can make a video on it. Thank you.